Good morning, ladies. Mr. O'Sullivan. Today we're going to be doing lesson 2-1. So we are finally in our first real geometry unit. We are going to be learning a lot about lines and angles in this unit. But before we jump into the lines and angles stuff, we need to make sure that we have a firm understanding of some basic geometric terms. And these are terms that you should have heard in middle school when you did your geometry unit in 8th grade or 7th grade. Here's the thing. We are going to be using these terms so much that I need to make sure that each and every single one of you know exactly what they mean, what they look like, and how we reference it when we're talking about them in questions. Because occasionally I'm just going to say P, and I expect you to know exactly what I mean by when I just say the letter P. Or if I draw something, I'm going to expect that you know that it's a line, a plane, or a point, and so forth. So the first thing we're going to look at is these things called undefined terms. So in geometry, we have these things called undefined terms, and these are examples of undefined terms: a point, a line, and a plane. So an undefined term is simply a term that has no formal definition, which sounds very bizarre because we always talk about how things have these definitions and how we can describe them. But the undefined term we only really identify by using these things called descriptors, so how we can describe them. So when I talk about a point, I'm talking about a specific location in space that contains no dimension and is simply represented by a dot. So when we talk about a point P, we represent it simply by using a dot, and we typically put the point name next to it. So right here I have a dot, and I can name this point P. So when I talk about point P, I can simply just use the capital letter P, or I can actually write out the word point P. Again, I can have about anything. And if you think about it, like when we're on our Zoom calls, you're all like little points on my screen, and your peers are also points on your screen because they're in different parts of three-dimensional space. A line. A line is a connected straight path that contains no thickness and continues forever and ever and ever in both directions. It's simply represented by a line with two arrowheads. So here's our visual of a line. As you can see, it has two arrowheads that go on forever and ever and ever in both directions. So I have an arrowhead here, an arrowhead here. And I can name this line as line AB, line BA, line AC, line CA, line ABC, or even line CBA. One thing that we should be comfortable with when we look at a line is that we don't need to name it by two endpoints. For instance, the reason why I can name this line AB is because I know that lines go on forever and ever and ever. So I know that eventually it's going to hit point C here. So I can name it line AB. I can name it line BC. I can also name it line any of these. And I can name it with 2 letters, 3 letters. I just can't name it with one point. So down here we have another example, and I named it just simply with L. So one of the things we can do is we can simply put a letter next to our line and basically name it something. If I wanted to, I could have also put like a Q here. And we typically use a script letter because mathematicians are very fancy when they do things for some reason. So if I wanted to, I could also name this line A, if I wanted to. And that's just some of the ways I can name a line. Now we're going to look at the word plane. A plane is simply a flat surface that contains no thickness, continues forever and ever and ever in all directions. It's typically represented by a parallelogram, so think of your desk, your chalkboard. Those are examples of a plane. I mean, they're not exactly a parallelogram, but it's basically a flat figure. And it's typically named by a single script letter or 3 non-collinear points. So if I look at this example up here, I have a plane that contains the points A, B, and C. If I want to, I can name it plane ABC. I can name it plane CBA. I could also name it even plane BAC. There's so many options I can do. And then down here, in this example of plane, I just have my fancy script letter P. So all I did was just name it plane P. Okay. Here are some examples of intuitive concepts. So when I talk about these intuitive concepts, they are, as you watch the edPuzzle, you're going to see visuals for each of these images. So if you want to take a quick screenshot or draw them in, it's completely fine, whatever you would like to do. So again, intuitive concepts. These are just a few basic concepts in geometry that need to be understood. They're rarely used as reasons in a formal proof. So for instance, one of our biggest topics that we study this year is proofs. which are basically a mathematical argument that we want to say about images or figures in our three-dimensional space. They're a very challenging topic, so it's very, very common that you will struggle with it, but I promise you that if you put in the effort and you really try your hardest, you will know how to do a proof. So collinear points are basically points that lie on the same line. The coplanar points are points that lie on the same plane. Opposite rays, we didn't get into rays yet, but opposite rays are two rays that lie on the same line with a common endpoint and no other points in common. And opposite rays form a straight line and or a straight angle, which are 180 degrees. Parallel lines are two coplanar lines that do not intersect, where again, you're going to be seeing all these visuals very shortly. And skew lines, which you might not have heard exactly called skew lines, you might have heard them called slant lines, but the proper terminology is skew. These are two non-coplanar lines that do not intersect. So if two lines were in the same plane, they would eventually intersect at some point, but we're not 100% sure where because of these flatness of the objects. All right, let's go on to the next part of our terminology for today. The defined terms. The defined terms are simply terms that are actually defined using the undefined terms that we studied on the page before, the point, the line, and the plane. We have these things called line segments and rays. Line segments, or we just call them segments, are a portion of your line. They are not the whole line. They are just a portion that we're going to focus on. They have two endpoints, but they have an infinite number of points between them. And they're always, always, always named by your endpoints. So for instance, we have these line segments right here. My first one I can call segment AB. I can also name it BA. I could say just segment AB, or I can draw like a little line segment over the letters AB and BA. That's another way I can say that I have a line segment. I also have a line segment XYZ, YZX, YZ, XY. There's so many ways I can name these line segments. Next, we have the ray, which is simply a portion of the line, and it only has one endpoint. The reason why it has one endpoint is because it's going to go on forever and ever and ever in one other direction. It will not go on forever and ever in both directions, because if it goes on forever and ever in both directions, you have a line. So it contains an infinite number of points as well, just like the line segment, and it's always named by one endpoint and one other collinear point, so a point that lies on the same line. So in our first visual, we have AB, and I can name that just by drawing a ray above the points AB. Now I have CD, but the thing is, instead of going to the right, it's going to the left. So a lot of students are going to be like, oh, I can write it as CD. But I can't, because if you look, I have it crossed out. The reason why I can't have it written like that is because if I have CD as my ray, then I'm saying that my endpoint C, and it goes on forever and ever and ever in this direction. So we always need to make sure that we are aware of the direction it's going in and aware of what our endpoint is. So for instance, D is my endpoint and C is my point that lies on the same line, or in this case, the ray. Theorems. We're going to be talking so much about theorems and postulates. Theorems are statements that can be demonstrated to be true by accepted mathematical operations or arguments. A postulate is a statement that is accepted to be true without proof. So for instance, the addition, subtraction, multiplication, division. You can do it on your hands, so we just assume it to be true. Now we're going to look at some of these theorems, and for each postulate, for each of these postulates, I'm going to put a visual on your edPuzzle. For instance, a line contains at least 2 points. Exactly one line passes through 2 points, and 2 points determine a line. If two lines intersect, they intersect at exactly 1 point. A plane contains at least 3 points that are not on the line. Exactly one plane passes through any 3 points which are not on a single line. If 2 points are in a plane, then the line containing them is also a plane. And if 2 planes intersect, their intersection is a line. You don't really need to know these, just be aware that these are some of the terminology we're going to be using. Planes aren't a huge part of our course. We mainly focus on the aspect of lines because lines are extremely, extremely important in three-dimensional space. Now let's do some practice. So for this visual, I want to name 2 line segments. I know that line segments don't go on forever and ever and ever. And just remember that when we name line segments, our direction doesn't matter at all when we name it. And we're going to name 2 line segments. I'm going to name at least 3, and I'm going to ask that you identify one yourself. So when I name these line segments, we really don't care about the order. So the first one I'm going to choose maybe you see it already, is I'm going to use B to D and name that a line segment. So I have BD, and make sure you put a line segment above it. I also have the line segment AC. And remember, they don't go on forever and ever and ever. They have a start point and an end point, and make sure you put your line segment above it. I also have CB. And remember, order doesn't matter when you're talking about it. Can you come up with a few others? Yes, AD and AB are examples of line segments as well, because remember, we have a start point and an end point. Now we're going to name some rays. And remember that when we name our rays, we always start with our endpoint first. So what I'm going to do right now is I'm going to erase my visual. What I'm going to do is I know that rays go on forever and ever and ever in one direction. So I'm going to start at the point B and go in the direction of C. So how I would name that is simply B, C, and I would draw a ray above it. I can also do this one. I can do A, D if I wanted to. And those are some examples of some rays. Now what we're going to do is we're going to name the line in 3 different ways. Now when looking at our image, we actually only have one line in our problem. And we know that lines go on forever and ever and ever in both directions. So the line that we're looking at is actually this one right here. Right here, the ones that contain B, C, and N. So we know that we can name a line using one letter, and it's right here. I can name this as line end. Line N. I can also name it as line BC. And I can also name it CB as well. And make sure that you draw a line above it. You can't draw a line segment, because if you draw a line segment, then you're going to say it's a segment. Now what we're going to do is we're going to name the plane in 3 ways. The first way I'm going to name my plane is just by using plane P. So I'm going to use my fancy letter P. And my P I'm going to try to make look fancy. Yeah, that's pretty fancy. That's my plane P. I can also name it as, and we want to make sure that when we name our plane, we use 3 non-collinear points. So I can use DAC, because I start at D, go to A, and end at C, because they're not on the same line. I can also use CAB. Just make sure that they are not on the same line. So C, A, B, and vice versa. So those are 3 ways I can name my plane. Now what we're going to do is we're going to name 3 collinear points. We know that collinear points are points that lie on the same line. So they're points that are typically all together. So if you look at your visual, what are 3 points that are all together? You got it. It's U, B, and H. So I can say U, B, and H are collinear points. Now, I want to say 3 non-collinear points. So these are 3 points that are not on the same line. There's a bunch of different combos you can use. I'm going to use E, X, and U because they're not on the same line. If you want to, you could also use U, B, and E if you wanted. Because as long as you have 3 points that are not on the same line, that's non-collinear. Opposite rays are those that go in opposite directions. So we want to look at 2 rays that go in opposite directions of each other, and they have to lie on the same line. So if I look at my visual very closely, I have a ray that goes from B through H, and I also have a ray that goes from B through U. So I have ray BH and ray BU as my opposite rays. And make sure you draw a ray above it. In our next example, we want to name line L using 3 letters. If we zoom in one more time, 1 second, line L is right here where UBH is. So I'm going to zoom in, and I can name it using 3 letters. I can say UBH, or I can say HBU. It's the exact same thing because they go in forever and ever and ever in both directions. Now, how many planes are shown in the figure below? So planes, we can simply count. They're just those little parallelograms or flat spaces. This is an example of a plane. 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 And this is an example of a plane. I've got 1, 2, 3, 4, 5. I have 5 planes. Now our next question is, how many of the planes contain the both points F and E? So I want to go into my visual. And I'm going to put my F and my E there. And if you look, they're part of this plane, and they're part of this plane. So if I count it correctly, they're only a part of 2 planes. And that's your final answer. So ladies, here's what you should do. Make sure that you have these definitions written down and you're familiar with them. If you want, make sure you go through and screenshot them, write them down though. It'll make sure it's in your brain. If you have any questions, email myself or Miss Daniel. Tomorrow we begin our topic where we actually look at the algebra of geometry. I promise you that this is going to be one of your last definition days for a while. It'll first pop up again in our next proof unit. Have a great day, ladies.